Okay students, let us try to solve this question. You can see the question is write the electronic configurations of the following ions. So that was the first part for solution, and where you need to find out the electronic configuration of the ions given. So the very first ion which is given to you is H minus. Now hydrogen, we know students, has atomic number 1. And how do we write its electronic configuration? We write its electronic configuration as, you can see here, we take the help of Aufbau's principle to write the electronic configurations. So here it has only got one electron, so we can see that we write 1s1. The first electron is filled in the first shell in the s orbital. So configuration for hydrogen atom is 1s1, but we are asked for H minus. Now here students, let us try to understand that the number of electrons which you have in a neutral atom is equal to the atomic number of the element. Atomic number of the element. This is when you need to understand, when for neutral atom. This is for your neutral atom. Okay. So for hydrogen, number of electron is 1. So atomic number is also 1. So the configuration is written as 1s1. But now we are to write for H minus. Now we know that minus means a species develops a negative sign over it after taking an electron. So here the total number of electrons, if you calculate for hydrogen, you already have 1 and it takes one more electron. So H minus will have 2 electrons into it. Therefore, the configuration for H minus will be equal to, for 2 electrons, it would be 1s2. The s orbital is filled. Okay. Now, similarly, for the second one which they are asking you here is your sodium ion. Right? Again, I told you that number of electrons is equal to atomic number. Sodium has atomic number 11, so it will have 11 electrons. Now, sodium ion we are to find out. So the number of electrons in, okay, here it is 11 electrons. Fine. Sodium will have your 11 electrons because atomic number is 11. Fine. Now when we talk about Na plus, plus indicates one electron is lost. So here you will have 11 minus 1. So Na plus has 10 electrons into it. Okay. So if we write the configuration now for Na plus, how it would be? We need to write the configuration of Na plus for 10 electrons. So how it should be? Start filling from here. You start 1s1. Okay, 1s2 is filled because s can accommodate maximum 2. Then let us fill the second one, that is 2s2. Then let us fill 2p6. Then 3s. Now just have a look. Should we fill anything in 3s? No, it's because we need to write the configuration of only Na plus with 10 electrons. So this 3s will be 0, or you don't have to write. Had it been Na, it would have been 3s1. So the configuration for your Na plus would be only 1s2, 2s2, 2p6, not with this. Okay. Now let us similarly try to understand for the third one. You are having the third is the configuration of O2 minus. Now I told you number of electron is equal to atomic number. Oxygen will have atomic number 8. So therefore it will have 8 electrons into it. Okay. Now if you talk about O2 minus, it indicates that oxygen has its 8 electrons, but minus indicates it takes 2 electrons. So O2 minus has total 10 electrons into it. And if you write the configuration for 10 electrons, it would be similar as we have done for Na plus above here. For 10 electrons only we have done. So it is 1s2, 2s2 and 2p6. Okay, now the fourth one you have is fluoride ion. Fourth one is your fluoride ion, F minus. Now fluorine has atomic number 9, so it will have 9 electrons into it, but we are asked to write configuration of F minus. Minus means it is taking 1 electron because only one minus sign is there. So 9 plus 1 electron will give you here also 10 electrons. So again configuration of F minus can be written here as the similar manner as we have done for your O2 minus and for Na plus. So it is 1s2, 2s2 and 2p6. So that was the first part, writing the electronic configuration of the ions. Now the next part or the next question is, what are the atomic numbers of the elements whose outermost electrons are represented by 3s1? So in second part you are having first question as electronic configuration for the outermost shell should be 3s1, 2p3 and 3p5. Okay, so it is for the first one is 3s1. Fine, let us take 3s1. So just try to write the configuration till 3s1. So use this Aufbau's principle. You will write 1s2 first, then 2s2, 2p6 and 3s1 till here. So 1s2, 2s2, 2p6, 3s1. Now just try to count the number of electrons. You have filled it till 3s1. 2 plus 2, 4 plus 6, 10 plus 1, 11. So you have filled all together 11 electrons till you have filled the configuration for 3s1. So now 11 electrons are present in the neutral atom of sodium. Okay, so therefore sodium is the element for which you are having the configuration. Okay, they are asking you the atomic number. Okay, so it is sodium having atomic number 11. The atomic number is equivalent to your electrons only, students. So atomic number will be your equal to number of electrons, and therefore it is sodium element. Sodium element has 11 electrons with atomic number 11. Okay, atomic number 11. Now similarly you are being asked for two more, that is 2p3 and 3p5. So 2p3 and third one is 3p5. So let us write configuration again since beginning. 1s2, 2s2, 2p3. So here you will see that total number of electrons you are having 4 plus 3. So 7 electrons you have, therefore atomic number would be 7 of whatever element. Okay, but we know that atomic number will be equal to 7. Therefore element, additionally I tell you that element for that would be, element is nitrogen. Okay, fine. They have just asked you the atomic number. But let us write the element also. Fine. Now next what you have is for 3p5. Similarly here also we will do the same. We will write the configuration till 3p5. So it is 1s2, 2s2, 2p6, 3s2 and 3p5. Now see how many electrons it has got in total. 10, 11, 12 and 15. 17 electrons are there in total in this. Therefore atomic number of the element is 17. And can you tell, students, which element has atomic number 17? Yes, it is chlorine. Okay, so 17 atomic number is of chlorine. Fine. So they were just asking you the atomic number, and we have also studied the elements which are possessing that particular element. Fine. Okay, now third question in this one is, which atoms are indicated by the following configuration? So if you will look at helium has configuration 1s2 and it is then followed by 2s1. So helium is having 2 electrons and 2s1 has 1 electron. Okay, so let us try to solve this also. So third part here, what you need to understand is about the configuration. In that also you are having 3 parts. First part is helium with 2s1. So it is, let us write helium with 2s1. Okay, now which element will be having this configuration there? Which atoms will be having this configuration they are asking you. So helium is having 1s2 configuration and 2s1. Okay, so the total number of electron is 3 electrons. Now 3 electrons which will be equal to atomic number as I explained earlier. So at 3 number, the element which you are having is lithium. Therefore it is lithium with atomic number, which can also be written as Li. Has atomic number 3, can be represented like this. Now for the other one, you are having the configuration as 3s2 and 3p3. Okay, with neon 3s2 3p3, it's neon. Okay, now you know that neon has got stable configuration for 10 electrons, which can be written as 1s2 2s2. For neon you can write it as 1s2 2s2 and 2p6. So we will take total number of electrons here. You have 10 plus this of 2 plus 3. So you are having 15 electrons overall. Therefore atomic number will be equal to 15. So which element has 15? Phosphorus. So the element is phosphorus. Okay, we represent phosphorus as P merely in symbolic representation, writing its atomic number below, which is 15. Right, now the last one which you are having is of your you can see here it is 4s2 3d1 with argon. 4s2 3d1 4s2 3d1 with argon. Now argon again is having a stable configuration with 18 electrons, plus 2 are filled in 4s and 1 is filled in d. So you will see that total number of electrons you are having is 21 electrons. So 21 atomic number will be there, that corresponds to your scandium. So the element which you have with 21 atomic number is scandium, represented as Sc. So I hope students you could understand the question step by step. The things which are asked are been discussed with you. Here the important thing is the filling of electrons, which you should know using your Aufbau's principle. Okay, order of subshell filling is given through Aufbau's principle, which helps us to write the electronic configuration of the element. So all the 3 sub questions are discussed in this question. I hope you have understood. Thank you all.